None of us ever dreamed that China would build a main sluice gate at the source of their water, launching a megaproject with a total investment of approximately 1.2 trillion yuan. It's not simply about damming the river, it's about channeling the water into the mountains to power 5 cascade hydropower stations. This transboundary river is being fitted with a superheart made in China. Its official name is the Yarlung Zangbo River Lower Reaches Hydropower Project, also commonly known as the Megadam Hydropower Project. Construction officially began on July 19, 2025 in Ningxi, Tibet. What's truly awe-inspiring is its chosen location, near the Yarlung Zangbo Grand Canyon, where the river makes a massive bend around Namchabawa Peak, a mere 50 kilometers long with a drop of nearly 2,000 meters. While other hydropower stations build high dams to create this drop, here nature seems to have pre-deposited an astonishing amount of gravity. How enormous is this deposit? One drop of water releases potential energy as it falls, and a natural drop of nearly 2,000 meters is equivalent to the river plunging from the top of a 100-story building. The core concept of the Yarlung Zangbo River Downstream Hydropower Project is not simply to build higher and higher dams, but to use tunnels and water diversion methods to divert some of the river water into the mountains, shortening the originally winding route and making more concentrated use of the natural drop in elevation. Humans haven't created energy, they've simply found a key to unlock the gravity reserves accumulated by the mountains over millions of years. Even more astonishing is that this isn't a single dam, but a super project consisting of 5 cascade hydropower stations. As the river flows downstream, the drop in elevation along its course can be utilized in segments. It's not about turning one drop of water into 5 drops, but about recovering energy segment by segment as the river flows downstream. According to public information, the project is expected to have an installed capacity of approximately 60 million kilowatts and an annual power generation of nearly 300 billion kilowatt hours. Both the expected installed capacity and annual power generation will significantly exceed those of the Three Gorges Dam. The Three Gorges Dam utilized a single drop in elevation, while this project aims to unlock the gravity reserves accumulated throughout the canyon. But the more impressive the figures on paper, the more arduous the construction will be. The canyons here are extremely deep, the mountains are steep, and rainfall is abundant. Construction also faces risks such as earthquakes, landslides, mudslides, and groundwater surges. While most engineering projects involve transporting machinery to the site before construction begins, here, roads, bridges, construction camps, and power transmission facilities must be built before large equipment can even approach. Once inside the mountains, construction workers face a maze-like landscape. Ahead might lie solid rock layers, where they might suddenly encounter fault lines, high ground stress, and surging groundwater. Every meter forward feels like a confrontation with a living mountain. Even more challenging is the immense pressure from the high waterhead. The force released by the river plunging down a huge drop is enough to quickly damage ordinary equipment. How can tunnels withstand this pressure? How can turbines withstand high-speed water flow? How can the surrounding rock remain stable? How can the project avoid high-risk areas for geological disasters? Any problem in any detail could be magnified many times by the Grand Canyon. Therefore, this project is not just a contest of concrete and steel, but a test of the limits of engineering capabilities, encompassing surveying, materials, equipment, monitoring, and control systems. Moreover, this is an important plateau ecosystem zone, and the larger the project, the more crucial it is that ecological protection cannot rely solely on slogans. During construction, continuous geological disaster monitoring and systematic prevention will be implemented, along with measures such as ecological compensation and vegetation restoration. True technological strength is not in daring to divert river water into the mountains, but in ensuring the long-term coexistence of the mountains and the project. Making the machinery run is not the most difficult part. The most challenging aspect is ensuring the dam remains stable and the river retains its vitality decades later. When this water is converted into electricity, new problems arise. Such a massive amount of electricity will primarily rely on external transmission for consumption, while also meeting local needs in Tibet. The river does not leave the valley, but the energy it carries can cross half of China. And this river will not end within China. After flowing out of China, the Yarlung Zangbo River enters India, becoming the Brahmaputra River, and finally flows into Bangladesh. Therefore, after the project commenced, India and Bangladesh quickly focused on water volume, water supply schedules, sediment transport, and project safety. However, it must be clarified that the initial main sluice gate is a visual representation and does not represent China's intention to permanently dam the entire river. Hydropower projects primarily utilize the drop in water level, with the river water driving the generators before returning to the riverbed. The Chinese side stated that the project will have no adverse effects on downstream areas and will continue to maintain communication on issues such as hydrological information, flood control, and disaster mitigation. Therefore, the Yarlung Zangbo River downstream hydropower project truly changes not just the river's power generating capacity, but also how humanity utilizes the natural drop in water level. In the past, this Grand Canyon was a daunting natural barrier. In the future, its accumulated gravity reserves, built up over millions of years, will be gradually unlocked by this megaproject. As the river flows through the mountains, releasing its energy in stages at the 5 Cascade power stations, this transboundary river will be equipped not just with power-generating equipment, but with a continuous beating heart on the plateau.